Welcome to Objective 58 and 59, Solving Radical Equations. Let's look at Roman numeral 1. It says simplify. So what would happen if we had the square root of 4 and then squared? So let's investigate this a little bit. If we had the square root of 4, we know the square root of 4 is 2, and then we would square it. That's equal to 4. Let's take a look at number 2. The square root of 9 squared. Well, we know that the square root of 9 is 3, and then we square it, that's 9. So what it looks like is happening is that we are getting the answer that is underneath the radical. If you look at it, we got 9, and there's a 9 under the radical. We got 4, and there's a 4 under the radical. So the big idea that we just saw from right there is that a square root is basically eliminated by a square. So that's important. That's going to be very important as we move forward here. So let's move on to the rest of the lesson. Solving equations with radicals. So we got to figure out some steps before we actually solve these. So when we look at the problems number 1 and number 2 below, there's going to be steps that we want to follow every time. So step number 1 is we want to isolate the radical. Step number 2 is that we're going to square both sides. Step number 3, we're going to eliminate the radical. Step number 4, we're going to solve. And then step 5, we're going to check our answer or our solution. So let's go ahead and try this in problem number 1. It says the square root of x plus 5 minus 6 equals 0. So if we follow step 1, isolate the radical. So what we have to do is we have to add 6 because we don't want that with the radical. So we have square root of x plus 5 equals 6. Step 2 says to square both sides. So we're going to square both sides. Step 3 says we eliminate the radical, because remember what we learned above was that a square and a square root, right here, a square and a square root cancel each other out. But on the right side, we have 6 squared, and we know that 6 squared is 36. Now we're on to step 4. Step 4 is solving. This is first semester stuff. We subtract 5, and we get x equals 31. The last step is it's very important in this chapter to check your answers. So we're going to check our answers. Square root. We're going to substitute in 31 for x plus 5. Subtract 6. And we need it to get equal to 0. So we're seeing if this is equal to 0. So inside the square root, we add them together. We get 36. We're still checking to see if it equals 0. The square root of 36 is 6. 6 minus 6 is 0. So that's true. So we know that this is a solution. Let's look at number 2. Wait a minute, number 2 has 2 square roots. So we go to step 1. We isolate the square roots. Well, each side has a square root. There's no other numbers anywhere, so we've technically isolated them by themselves on each side. So now we move on to step 2. In step 2, we square both sides. Step 3 says eliminate the square roots, because remember, a square and a square root basically eliminate each other. So now we write down what's under the square roots. And now we just solve the problem. So I'm going to go ahead and subtract 5x. That's going to give me negative 3x minus 6 equals negative 3. Then I'm going to add 6. That's going to give me negative 3x equals 3. Divide by negative 3. I get x equals negative 1. Now again, I want to check. So I'm going to go up to the original problem, and I'm going to substitute negative 1 in for x. So I have 2 times negative 1 minus 6. And I'm going to check to see if it's equal to the other side, which is the square root of 5 times negative 1 minus 3. So on the left side, I get the square root, and I get negative 2 minus 6. On this side, I get the square root of negative 5 minus 3. So I get the square root of negative 8 and the square root of negative 8. So you're going to learn in Algebra 2 that this is technically square root of negative 8 is not possible. It's a non-real answer. However, when we plugged in negative 1, we did get the left side equal to the right side, so therefore this is a valid answer. As long as your left side equals your right side, you're good to go. Let's move on. What is an extraneous solution? So an extraneous solution is basically a solution that will not yield a true statement. Oh. A true statement. So let's take a look at this in number 3. Number 3, let's follow our rules. Isolate the square root. Well, right now out in front there's a 2 times the square root. We want a square root by itself. We want nothing on that side other than the square root. So to undo multiplication, the first thing we have to do is we have to divide by 2. Because we want to isolate that square root. And by doing that, we cancel out the 2's. That leaves us square root of 2x minus 4 equals negative 4. Now we square both sides. Next step, we eliminate the radical. On this side, negative 4 times negative 4 is positive 16. Now we solve, add 4. Divide by 2. We get x equals 10. So let's check this problem. We had 2 square root 2, substitute in 10 for x. minus 4. And we're checking to see if it equals negative 8. So we get 2 square root 20 minus 4. That's 2 square root 16. The square root of 16 is 4. So we get 2 times 4 is 8. 8 is not equal to negative 8. So this is false. So this is an example of extraneous solution. X equals 10 was what we got, but we know that x equals 10 is false when we plugged it in. So technically, this problem has no solution. That's what it means to be an extraneous solution. It did not yield a true statement. I'll leave you with the riddle and I'll let you know the answer tomorrow. The more you take, the more you leave behind. What are they? Good luck, ladies and gentlemen.